Hello everyone, welcome back to our second lecture on Introduction to Databases. Today, we'll explore the different types of databases and dive into the world of database management systems, DBMS. Let's get started. A database management system, DBMS, is a collection of programs that facilitates users to create, define, manipulate and manage databases. DBMS acts as a bridge between users, applications, and the actual database. It handles tasks like data storage, retrieval, data security, and data integrity. Essentially, DBMS is the powerhouse behind a well-functioning database. A database management system, DBMS, is like a middleman between the user, or application, and the database. The database is a collection of files that store information, and the only way to access that information is through the DBMS. The DBMS makes things easier for the user by providing a single, organized view of the data in the database. It takes care of complex operations to fulfill the user's requests and hides the complicated inner workings of the database from the user or application. Imagine the DBMS as a bridge that connects the user's application, like a program written in Python or Java, to the database. This setup offers some important advantages. First, it allows multiple applications or users to share and access the same data. Second, it brings together different views of the data into one big, comprehensive database. Since data is crucial for getting information, managing it efficiently is essential. The DBMS helps in doing just that, making data management more efficient and effective. Components of a DBMS. A DBMS is made up of several components that work together to ensure the efficient use and management of data. At its core, we can summarize 6 components. 1. Hardware. This refers to the physical devices, including the computer itself, that are used to store the data. Some examples of hardware used in a DBMS include computer, hard disks, I/O channels. 2. Software. The software component of a DBMS refers to the computer programs used to manage the database. This could include the DBMS itself or supporting software like drivers or utilities. Simply put, the software is a layer that is supported by the hardware to create a visual interface for the user to interact with to control the database. 3. Data. The data generated by an organization is the lifeblood of a DBMS. Data is the resource that is stored within a database. Metadata, which is information about the data, is stored within a DBMS as well. This information provides some context about the data and helps to ensure that it is maintained, secured and accessed correctly. For example, metadata could include information like the type of data, its size, and the time it was created. 4. Procedures. DBMS procedures are the guidelines that dictate how the database is set up and should be used. These procedures govern how data is accessed, modified and archived. In simple words, these are the instructions on how a DBMS should be used. 5. Database Access Query Language. When accessing a database, users must use a specific query language that the DBMS understands. These languages can be generally split into 4 categories. Data Definition Language, DDL. Data Manipulation Language, DML. Data Control Language, DCL. Transaction Control Language, TCL. These languages play a part in searching, fetching, updating and adding data to the database. Without the use of languages, the database cannot be accessed easily through interfaces. We will be learning Structured Query Language, SQL, in this course as it is supported by majority of DBMS vendors. 6. Users. Users are the people who interact with the database using the DBMS software. Users can have different roles and privileges depending on their purpose and level of access. For example, Database administrators are responsible for creating, maintaining, and securing the database. Database developers are responsible for designing and implementing the database schema and logic. Database analysts are responsible for analyzing and optimizing the database performance and functionality. End users are responsible for using the database for their specific needs or tasks. Types of databases. There are many types of databases depending on how they store and organize data. The most common types are relational databases, non-relational, NoSQL, databases. Relational databases. Relational databases are based on the relational model proposed by Edgar F. Codd in 1970. In this model, data is stored in tables consisting of rows and columns. Each column represents an attribute or property of an entity or object, and each row represents a record or instance of an entity or object. For example, this table represents a relation or a set of customers. Each customer has 4 attributes: customer ID, name, email, and phone. Each customer is identified by a unique customer ID, which is the primary key of the table. Relational databases use structured query language, SQL, to manipulate data. SQL is a standard language that allows users to perform various operations on data, such as creating tables and defining their structure and constraints, inserting, updating, deleting, or querying data, joining multiple tables to retrieve related data, applying functions, aggregations, or calculations on data, creating views, indexes, triggers, or stored procedures. Some of the advantages of relational databases are: they are easy to understand and use because of their tabular structure and SQL syntax. They ensure data integrity and consistency by enforcing rules and constraints on data. They support complex queries and operations on data using SQL features and functions. They are widely used and supported by many DBMSs, such as MySQL, Oracle, SQL Server, PostgreSQL, etc. Some of the disadvantages of relational databases are: they may not be suitable for accommodating big data and web-scale databases that contain large amounts of unstructured or semi-structured data, such as text, images, videos, etc. They may not be able to handle high concurrency and scalability demands due to their rigid schema and atomicity, consistency, isolation, durability, properties. They may suffer from performance issues due to the need to join multiple tables or normalize data. Non-relational databases. Non-relational databases are also known as NoSQL, not only SQL, databases. They are based on different models that do not follow the relational model or use SQL. Instead, they store and organize data in various ways, such as key-value pairs, example, Riak, Voldemort, and Redis. Documents, example, MongoDB. Graphs, example, Neo4j and HyperGraphDB. Columnar, example, Cassandra and HBase. For example, this document represents a customer and their orders in a document database. A document database stores data in JSON-like documents that can have nested structures and varying fields. Each document has a unique key that identifies it. Non-relational databases use different query languages or APIs to manipulate data depending on their type. For example, key-value databases use simple commands like get, set, delete to access data by their keys. Document databases use query languages like MongoDB Query Language, MQL, or Couchbase N1QL to access data by their fields or values. Graph databases use query languages like Cypher or Gremlin to access data by their nodes or edges. Columnar databases use query languages like Cassandra Query Language, CQL, or HBase Shell to access data by their columns or families. Some of the advantages of non-relational, NoSQL, databases are: They are flexible and adaptable to handle unstructured or semi-structured data that may have varying schemas or formats. They are scalable and performant to handle large volumes of data and high concurrency demands by using distributed architectures and techniques like sharding, replication, or caching. They are suitable for specific use cases that require specialized features or functionalities, such as real-time analytics, social networks, content management systems, etc. Some of the disadvantages of non-relational, NoSQL, databases are: they may not ensure data integrity and consistency as much as relational databases due to the lack of rules and constraints on data. They may not support complex queries and operations on data as much as relational databases due to the limitations of their query languages or APIs. They may not be compatible with existing tools or standards that rely on SQL or relational models. Conclusion. In this lecture, we have learned about what DBMS are, why they are important, components of DBMS, how they help us manage and use databases effectively, and what are the different types of databases. We have seen that there are two main types of databases, relational and non-relational, NoSQL. Each type has its own advantages and disadvantages depending on the nature and purpose of the data.